Welcome to Exploring Computing. Today's video is creating web pages, specifying colors. So if you haven't already watched the hexadecimal numbers video, watch that first. Hexadecimal numbers are critical to working with colors on web pages. For CS105 students, that video is in the same folder as this video. For CS106E students, we covered hexadecimal numbers last week in the LO6 memory lecture series. Also, as a reminder of how the computer actually generates colors, it mixes the amount of red, green, and blue on each of the subpixels composing each of the individual pixels in the screen. So remember, when we're specifying colors, we're specifying the intensity of red, green, and blue. We learned that the first week in the lecture on images. Okay, so let's start off with a little history lesson. This will tie back in. Once upon a time, we had only 16 named colors. And here they are. So we'll see in a minute, you guys have it much better off. But there was another big problem that we had, which was that the computer monitors only displayed 256 colors. And it turns out that the computer manufacturers could not agree on what those 256 colors were. So there were only 211 colors that were agreed upon by all the computer manufacturers, and these were referred to as the web-safe colors. So if you see the term web-safe color, that's what they're referring to. It should not be an issue any longer because any modern computer display or mobile device should display 16.7 million colors or more. I don't think you're going to run into devices that only have 256 colors, but you will run into the term web-safe color. That is what it's referring to. Okay, what do we have now? Well, as far as named colors go, there are 148 named colors. And as we've talked about previously, there are 16.7 million colors, as you learned about in the first week, how computers store and display images. And in addition to having 16.7 million colors, we also have 256 levels of transparency. In computer science, we usually refer to this as alpha, but it corresponds to either transparency or its opposite, opacity. The named colors are what are sometimes referred to as the CSS3, that's Cascading Style Sheet 3. There are several versions of Cascading Style Sheets. They're starting to work on Cascading Style Sheets 4, but they haven't really finished Cascading Style Sheets 3 yet. Cascading Style Sheets 3 had an extended color standard, and these are referred to as the CSS3 extended color keywords, or the SVG, that's scalar vector graphics, which we talked about briefly in our lecture on image representation. That's the object version of storing image information that is available on the web. We may talk about that again in more detail in another lecture. It's also referred to as the SVG 1.0 color keyword names. These are sometimes also referred to as HTML5 colors, although that is not technically correct. You may also hear them referred to as just CSS colors. I'm not going to list all 148 of them, but this kind of gives you a feel for what sort of options you have available. There are quite a few options. There's a lot going on there, but they are nowhere near the full color palette. Remember, we can represent 16.7 million colors, and the extended color keywords only give us 148. So I think they're fun, if nothing else, and they may give you some ideas on colors to play with, but they're not. They're fairly limited. Now, when we're looking at these sample lists here, we've got the name, that's pretty obvious what that is. And then we have the representation of the color, that's pretty obvious what that is. And then what is between those two, that thing that starts with a number sign? Well, if you've watched the hexadecimal video, you will know that that is the hexadecimal color specification. And if you haven't watched the hexadecimal video yet, watch the hexadecimal video. All right, so as we saw in the hexadecimal video, and as you'll recall from our discussion on computer displays and images from the first week, computers use 24-bit color or 32-bit color. And in either one of these two schemes, Colors are represented by mixing red, green, and blue light. And red corresponds to a single byte, green corresponds to a single byte, and blue corresponds to a single byte. That gives us decimal numbers between 0 and 255, but it gives us hexadecimal numbers between 0, 0, and FF. And for the web, they're traditionally represented as hexadecimal numbers. And so here we've got cardinal red, and it would be represented by the sequence 8C1515. So 6 hexadecimal digits, 2 hexadecimal digits for red, 2 hexadecimal digits for green, 2 hexadecimal digits for blue. And as you'll recall from the hexadecimal discussion, each hexadecimal digit corresponds to 4 bits. So 2 hexadecimal digits corresponds to 8 bits, which is a byte. So that's where we get our 6 hexadecimal digits, 24-bit color. I think the most important thing to understand as far as hexadecimal goes when we're working with HTML and web pages and cascading style sheets and colors is how to make adjustments. So here I've got crimson red, and we're using crimson red, although we saw cardinal red a moment ago because cardinal red is perfect. We don't want to modify cardinal red, but we might want to play with our crimson red. So this is crimson red, DC143C. And so when you're looking at this color, you might think, I think there's a little bit too much red. So what you want to do is you want to be able to look at this and say, well, that first pair of hexadecimal digits at DC, that's the amount of red. And so I can move the amount of red up or down. So like if I wanted to move it up, if I wanted to move it up slightly, what it comes above DC, well, DD comes above DC, and then DE, and then DF, and then E0, all right? Or we can go in the other direction and say, okay, DC is too much. Let me reduce it very slightly, DB, DA, D9, D8. And so be able to move up and down. Now, you're probably not going to be moving up by increments of 1. That's really, but maybe your eyesight and artistic abilities are such that you might notice the difference. I'm not going to be able to notice the difference. So I would move it up much more or move it down much more. So here I've moved it down to AC, and you can see that this is a considerably darker red than we started off with. So, again, say we wanted to adjust the amount of blue. Maybe we want a little bit more blue. So I remember, okay, AC, that's now our red, 1,4, that's our green, and 3C is our blue. And so if I want to move blue up, 3C, what comes after 3C? 3D, 3E, 3F, 4, or if I want to go down from 3C, 3B, 3A, 3.9, and so on. Again, those are minor adjustments. I'm going to make a much bigger adjustment here. I'm going to take the 3C and just boost up to 5C. And you can see the results here. So basically, you want to be able to take these color specifications and have a good enough understanding of hexadecimal to be able to make adjustments up or down. So focus on understanding how to increase and decrease the hexadecimal numbers rather than worrying about how to convert to decimal. Now, if you look at this little overlay that I've got here, you may notice that you can kind of see the color squares behind it. And so this is an example of using alpha. So alpha controls, again, either the opacity or the transparency. The two are basically opposites. Opacity says, how much are we preventing the light from coming through? And transparency says, how much are we allowing the light to come through? So in addition to being able to specify the amount of red, green, and blue we have, we can also add in 4th pair of hexadecimal digits to control the alpha. So here, 8C1515, that's our crimson red, but that's actually equivalent of 8C1515, that's RGB, and then FF, that is that last set of hexadecimal digits is the alpha. And with FF, that's the maximum that we're allowed to specify. And so this is full opacity. This means we cannot see through this at all. And so you can see the example overlay title and then a crimson background using the color I've specified here. And you cannot see through that crimson at all. So we're going to reduce it slightly. Here's 75%. I've gone from FF to BF. And if you look at the example overlay over our image of Venice, you can see you're starting to be able to see Venice through the crimson background there. And that's because it's not at full opacity. It's now at only 75% opacity. We can lower it even more. This is about 50% opacity. I specified that last pair of, that fourth pair of hexadecimal digits, again, representing the opacity. I've cut it down from FF all the way down to 80. So this is basically halfway. And you can see a lot more of the background showing through. So that kind of gives you an idea of how to play around with the alpha if you want to do that. You can also use 3 or 4 digit colors instead of using 6 or 8 digit colors. And so what happens here is we take, let's start off with a 3-digit example. We take our original RGB and we just get rid of, half the number of letters. So as long as our pairs are, both the 10s, well, they're not really 10s, I suppose they're 16s. As long as the 16s and the 1s are the same, if we were using decimal, it would be the 10s and the 1s. We can immediately convert it to 3 hexadecimal digits. And I've written these down as they're equal. That's not really true. It's more the FF is transformed into FFF. They're not, if we were to do the actual conversion in base 16, these of course are not equal. But as far as how they're specified in this three digit scheme for colors, that's the way it works. So similarly, CC9900 can just be written as C90, and 11AA33 could be written as 1A3. If you work this out, what ends up happening here is we're losing the number of colors we can specify. With our original 8 hexadecimal digit scheme, remember that corresponds to 24 bits. And so 2 to the 24 gives us 16.7 million colors. With the 3 hexadecimal digit scheme, we've only got 12 bits. And so that gives us 2 to the 12th, which means we have 4,096 colors. So basically, you're losing the ability to specify a lot of colors. But, unless you're fine-tuning things, you may not notice. It just really depends on what you're doing. And you can also specify these with 4 hexadecimal digits, where the 4th hexadecimal digit corresponds to the amount of alpha. So how do we take these specifications and actually use them on a web page? So here's a short little example showing how I've used some colors. So I've created a style sheet. I'm specifying a style rule for the body, and you can see I'm providing the color and background color properties. And for color, I'm just using one of those predefined color names, wheat. And then for the background color, I'm using my hexadecimal specifications. Take the specifications we've been showing you here and slap them in the style sheet anywhere a color is expected. Now, if you are hexadecimally challenged, it is possible to do it without the hexadecimals. Traditionally, it is done by hexadecimals, and the hexadecimal colors are going to show up in a lot of places. So, I do think that you should try and get at least some familiarity with them. You should be familiar enough with them that when you see them, you're like, oh, that's a color. And I can kind of get a sense by looking at the R, the G, and the B at more or less what it might look like. But if you really don't want to specify the amounts in hexadecimal, you can specify them either as percentages or as just straight decimal numbers. So this is going to be, instead of specifying the number as number sign, hexadecimal pair, hexadecimal pair, hexadecimal pair, you can specify it by writing RGB and then giving a set of percentages for red, green, and blue. Or you can give numbers between 0 and 255. This also works for alpha. You specify alpha as a percentage. And then finally, we'll talk about this later in the quarter when we're talking about website design. But depending on what you're doing, you may want to specify, instead of RGB, you could specify using hue, saturation, and lightness. This will be useful when you're trying to choose color schemes. And again, we will talk about this later. And here's what this looks like on an actual web page inside the style sheet. All right, so this is kind of giving me a sense of how colors are specified on web pages. And now between the images we talked about earlier and the colors we specified here, you should be able to make much more interesting and fun web pages. I'll talk to you soon.